Alright, this is going to be our walkthrough for the homework assignment titled Derivative Motion. This is going to be basic physics application problems. And as we go through here, hopefully none of these end up being too terrible. We should be able to do all of them without a calculator. And so we'll start here. We got a particle that's moving according to the position. S of t equals t squared minus 10t plus 12. We'll note t is in seconds and s is in feet. We want to find the velocity function. Well, we know that the instantaneous rate of change of the position is the velocity. So the velocity function, v of t, should just be s prime of t, the derivative of the position, which is 2t minus 10 using the power rule. The acceleration function, well, acceleration is the instantaneous rate of change of the velocity. So the derivative of 2t minus 10 is just 2. If we want to know when the particle is at rest, a particle is at rest when its velocity is equal to 0. So we'll say when v of t, which is 2t minus 10, equals 0. Well, just add the 10 and divide by 2, we'll get t equals 5 seconds. That's when the particle is at rest. The fourth part here, what is the acceleration at t equals 1? Well, the acceleration is always 2. Like we just found in part B. So at t equals 1, it's also 2, and it's 2 feet per second, or feet per second squared. If we want to know the velocity at t equals 1, we just take our velocity function and evaluate it at 1. So that'll be 2 times 1 minus 10, which is negative 8 feet per second. And if we want to know at what time the velocity is 3 feet per second, we'll just set our velocity function, v of t, which is 2t minus 10, equal to 3, and solve for t. And if you just add the 10 and divide by 2, you'll get t is equal to 13 halves seconds, or 6.5 seconds would be fine too. But yeah, either way is good. And that's our first basic motion problem. This second one here is going to be pretty similar. This time our particle is moving with a different position function, it's cubic, but that doesn't really change the process. To find the velocity function, we'll still just take the derivative of the position function, and that'll be done using the power rule. We'll just get 3t squared minus 18t plus 15. And to find the acceleration function, we'll just take the derivative of the velocity function, which again we'll use the power rule and get 6t minus 18. If we want to know when the particle is at rest, we just need to set our velocity function equal to 0. So 3t squared minus 18t plus 15 equals 0. Well, we can divide everything by 3 there. That 3 doesn't really matter. That'll give us t squared minus 6t plus 5 equals 0. Or when we factor t minus 5 and t minus 1, giving us t equals 5 seconds and t equals 1 second as our two answers. For the next part here, what is the acceleration at t equals 4? We just need to evaluate our acceleration function at 4, so that'll be 6 times 4 minus 18. Well, that'd be 24 minus 18, which is 6 feet per second, or 6 feet per second squared. To find the velocity at 2 seconds, we'll just evaluate the velocity function at 2. So that'll be v of t, which is 3t squared, so 3 times 2 squared, minus 18 times 2 plus 15. Well, 2 squared is 4, 3 times 4 is 12, so we got 12 minus our 18 times 2, that'll be minus 36, and then plus 15, and if you just do your arithmetic there, you ought to get negative 9, and it's feet per second. And our last one is, at what time is the velocity 3 feet per second? Well, just set your velocity function, 3t squared minus 18 t plus 15 equal to 3. We can divide everything by 3 again. So t squared minus 6t plus 5 equals 1. Or t squared minus 6t. And I'll probably choose, you could use quadratic formula, or you can complete the square here. I'm going to complete the square. I always prefer to complete the square. So I'll just subtract the 5 over and say equals negative 4. And to complete the square, remember that we just take the b value, which is negative 6, divide it by 2, and then square it. So negative 6 over 2 is negative 3, squared is 9. We'll just add 9 to both sides, which is going to give us, when we factor, t minus 3 squared is equal to negative 4 plus 9 is 5. We'll square root both sides to get t minus 3 equals plus or minus root 5, and t equals 3 plus or minus root 5 seconds. And we'll note that there are two answers to that. Right? 3 minus root 5 is a positive value of t, and so is 3 plus root 5. So we've got two different values there. All right, for our next one here, we've got a bullet being fired straight up off the surface of the moon. We've got a position function for that, 832t minus 2.6t squared. And then on Earth, we've got a different height, 832t minus 16t squared. We want to know how much longer it's going to take the bullet to hit the ground on the moon than it would on the Earth, and we want to know the velocity of the bullet on the moon and on the Earth when it hits the ground. So, if we want to know how long it takes for it to hit the ground, we just need to figure out when the position function is equal to 0 for each of them. So we'll set 832t minus 2.6t squared equal to 0. This is for the moon. And then for Earth, we're going to set 832 minus 16t squared equal to 0. That'll tell us the time at which this bullet is at the ground. We can factor out a t. So t times 832 minus 2.6. 832 minus 2.6t is equal to 0. And then that gives us either t equals 0, which is when it starts, or if we take 832 and divide it by 2.6, that will give us 320. So t equals 320 seconds is how long it's going to take for the bullet to hit the ground on the moon. And on Earth, we'll do the same thing. I forgot the t there. We'll factor out the t. T times 832 minus 16t is equal to 0, which gives us t equals 0. And when you do 832 divided by 16, that just comes out to be 52. And so we've got 52 seconds for this one to hit the ground, so much quicker. And to figure out, it says, the question actually asks how much longer does it take. So we'll do 320 minus 52 seconds should be 268 seconds longer. And so that's the first part of the question. No calculus really needed there. Second part of the question is, what is the velocity of the bullet on the moon and on the Earth when it hits the ground? Well, the velocity of the bullet for the moon should just be the derivative of the position function, which will be 832, and then the minus 2.6t squared will become minus 5.2t. And on Earth, it'll be very similar. We'll still have 832, but now it's minus 32t. And if we want to evaluate them both for when the bullet hits the ground, this one, the velocity will be at 320 seconds. So that gives us 832 minus 5.2 times 320. I'll spare the arithmetic there. That ends up being negative 832 feet per second. And on this one, we're going to do the evaluation at 52 because that's the time at which that bullet hits the ground. So it'll be 832 minus 32 times 52, and as it should, that also comes out to be negative 832 feet per second. So it takes a lot longer for it to hit the ground on the moon, but it's still traveling at the same velocity at that time. All right, for our next one here, we've got a particle moving along the x-axis, and it's got a position for any time t greater than or equal to 0, equal to inverse sine of root t over 4. We want to find the velocity when t is 4. So first we just need to find the velocity function, right? X prime of t will be velocity. And to do that, we need to take the derivative of the inverse sine of root t over 4. So, well, the inverse sine is 1 over root 1 minus the function squared. The function is root t over 4. So we'll write root t over 4 squared, and then we have to multiply that by the derivative of root t over 4. Well, the 1 over 4 part's just a constant in front of it, so we'll do 1 over 4 and 1 over 2 root t. So if we do a little simplification here, we should see that this becomes 1 over, and then the square root there is the square root of 1 minus, if I square root t, I just get t, and 4 squared is 16. And then we're going to multiply that by 1 over 8 root t. And we want to know what this is when t equals 4. So if we evaluate this at t equals 4, we're going to get 1 over the square root of 1 minus 4/16, or 1 minus 1/4, times 1 over 8 root 4. And of course, 8 root 4 is 8 times 2. So that part's going to be 16 in the denominator. So we have 1/16. And then over here we have 1 over root 3/4. Well, 1 over root 3/4, that's the same as 2 over root 3, right? If we rewrite that, it's 1 over root 3 over root 4 times 1/16. And if I take the reciprocal of root 3 over root 4, I'm going to get 2 over root 3, right? If I square root the 4, I get 2 times 1 over 16, which is 1 over 8 root 3. And our units here for velocity are going to be feet per second. All right, here we've got a weather balloon's being released, rising vertically, and its distance during the first 10 seconds is given by this s of t function, 6 plus 2t plus t squared, where the distance is in feet and the time is in seconds. So if we want to figure out, first off, the velocity at 1, we need to find v of t, which is s prime of t, which will be 2 plus 2t, just using the power rule. So v of 1 will just be 2 plus 2 times 1, or 4 feet per second. V of 4 will just be 2 plus 2 times 4, which ought to be 10 feet per second. And v of 8 ought to be 2 plus 2 times 8, which will be 18 feet per second. Pretty straightforward there on the first one. We want to find the velocity of the balloon when it is 50 feet above the ground in the second part here. So all we need to do is first find the time when the balloon is 50 feet above the ground. So we'll start by setting our function t squared plus 2t plus 6 equal to 50. We can choose to either solve this using the quadratic formula, or we can solve this by completing the square. Again, I may have used the quadratic formula in the answer key, but I always prefer to complete the square if it's an easy one to do it with. So I'll subtract the 6. 50 minus 6 is 44. And when I take half of 2 and then square it, that's just 1. So I'll add 1 to both sides. So when I factor, I end up with t plus 1 squared equals 45, or t plus 1 equals plus or minus root 45, which ends up giving us t equals negative 1 plus or minus, and if I simplify root 45, that ought to be 3 root 5. And so all we're really being asked of here is to then evaluate the velocity at whichever one of those times makes sense. Well, the first 10 seconds of flight mean that I'm going to have a positive value for t. And if I look at t equals negative 1 minus 3 root 5, that is certainly not a positive value of t. So we're going to use t equals negative 1 plus 3 root 5, and we'll evaluate the velocity function at that value. So v of negative 1 plus 3 root 5 is just going to be 2 plus 2 times negative 1 plus 3 root 5, which ends up giving us, well, 2, and then the minus 2 will cancel out, so we just end up getting 6 root 5, and our units are, once again, feet per second. And for our last part here, we just want to find the acceleration of the balloon at any given time t equals a, any time. So we just need to take the derivative of our velocity function. Well, our velocity function was just 2 plus 2t, so its derivative is 2, and the units will be feet per second squared. And at any value of a, our acceleration should be 2. Right? The acceleration is constant for this balloon. All right, for our next one here, we've got a ball rolling down an inclined plane. We've got a distance in centimeters that it rolls in t seconds, given by that cubic, 2t cubed plus 3t squared plus 4. We want to find the velocity at t equals 2, so we'll just find the velocity function by finding the derivative of the position function. That'll be 6t squared plus 6t. And so then we want to find the velocity at 2, so we'll just evaluate that at 2. Well, 6 times 4 is 24, 6 times 2 is 12, we end up getting 36. This time our units are centimeters per second. We want to know at what time is the velocity of the ball 30 centimeters per second. So we just need to set our velocity function, which we just found, 6t squared plus 6t, equal to 30. And these can all be divided by 6 here, so we'll end up with t squared plus t equals 5. Or, since that one's not as nice for completing the square, t squared plus t minus 5 equals 0, and it doesn't factor. So we can use the quadratic formula. T should be equal to, the quadratic formula says the opposite of b, so negative 1, plus or minus the square root of b squared, 1 squared, minus 4 times a, which is 1, times c, which is negative 5, all over 2 times a. And I think we can see that we end up getting t equals negative 1 plus or minus root, well, inside of there we have 1 plus 20, so 21 over 2. There's no simplification there for root 21, right, because the prime factorization of that is 3 times 7. So we just have to decide which of these makes sense. And a negative 1 minus a root 21 is clearly a negative time, so we're going to disregard that. And our answer will be negative 1 plus root 21 over 2 seconds. And that'll be the time when our velocity is 30 centimeters per second. And lastly, we just want to find the acceleration of this ball at a couple of different times. So we need to find v prime of t, which is our acceleration function. Well, the derivative of 6t squared is just 12t, and the derivative of 6t is 6. So we have 12t plus 6, just evaluate a of 1, which ought to be 12 plus 6, or 18 centimeters per second squared. And to find a of 2, just evaluate that at 2, which ought to be 12 times 2 plus 6. 24 plus 6 is 30, so 30 centimeters per second squared. All right, next one here, we've got a penny that is being dropped in a vacuum from a height of 1,920 feet, and we've got this equation here, negative 16t squared plus 1920 is our position, and it looks like we've forgotten where we'll measure this in, the position is measured in feet, and we'll say that t is in seconds. And we want to find the instantaneous velocity of this penny that's being dropped. Well, just find s prime of t. Well, the derivative of that will just be negative 32t. And it says at any value a, so that will be, replace the t with an a. So negative 32a, and the units on that would be feet per second. To find the instantaneous velocity at 2 seconds, we just need to evaluate that when t is 2. So that'll be negative 32 times 2, or negative 64 feet per second. To find the velocity at 5, we'll just evaluate negative 32t when t is 5. Well, 32 times 5 is 160, so that'll be negative 160 feet per second. And lastly, we want to find the velocity when the penny hits the ground. Well, the penny hits the ground when its position is equal to 0. So we'll set s of t, negative 16t squared plus 1,920, equal to 0. And solving that, if we subtract the 1920 and then divide by negative 16, at 1,920 divided by 16 is 120. So we get t squared equals 120, or t equals plus or minus root 120. I'm not going to bother with the minus because we're not going to have negative times. And you can take a, seems like a 4 is the largest perfect square that 120 divides by, so we'll call this 2 root 30 is our time. We want to find the velocity at that time. So our velocity function was negative 32t. So we'll just do negative 32 times 2 root 30, which ought to be negative 64 root 30 feet per second. All right, just a couple more here to go. We've got a toy rocket that is being projected upwards with a velocity of 192 feet per second. And the launch pad is 9 feet above the ground. So the position function here is going to be s of t is negative 16t squared plus 192t plus 9. Well, the maximum altitude that we're looking for would be when the rocket stops going up and starts going down. Right? And so that would be when, in order to stop going up and start going down, its velocity would have to be equal to 0. So let's first find the velocity function. V of t should be negative 32t plus 192, and we'll just set that equal to 0. And we should see that subtract the 192, get negative 32 equals negative 192, and 192 divided by 32 is 6. So it takes 6 seconds for it to reach its maximum altitude. So to find the actual altitude means we just need to evaluate the position of this rocket at 6. So s of 6 will be negative 16 times 6 squared plus 192 times 6 plus 9. Negative 16 times 36 plus 192 times 6 plus 9 is 585. So 585 feet is the maximum height that that rocket hits. Alright, and our last one is a weather balloon that's being released and rising vertically so that its distance above the ground during the first 14 seconds of flight is given by this position function 10 plus 2t plus t squared. We want to find the velocity of the balloon when it is 130 feet above the ground. So first off, we need to figure out when is this balloon 130 feet above the ground. So set the position function equal to 130. If we get everything to one side in this quadratic, we have t squared plus 2t minus 120 is equal to 0. And it looks like that actually factors out really nicely. Right, we can factor that into t plus 12 and t minus 10, telling us that t equals negative 12 and t equals 10 seconds are when this should be 130 feet above the ground. Well, t equals negative 12 is, of course, just ridiculous. We're not going to have negative time values, so we're going to use t equals 10. And we want to know the velocity at that time, so we need to find s prime of t, which is v of t. Well, the derivative of 10 is 0, the derivative of 2t is 2, and the derivative of t squared is 2t. So if we evaluate the velocity at t equals 10, we just have 2 plus 2 times 10, which is 22 feet per second. And that's the end of the derivative motion homework assignment.